Good morning to all. Myself, Dr. Arun from Aerospace Engineering Department. Today, I am going to take one topic from fluid mechanics for aerospace subject for second year students. So, if the topic name is laminar and turbulent flow. So, today we are going to take the Reynolds experiment for laminar and turbulent flow. Here, what is meant by Reynolds number? Reynolds number, it is a ratio of inertial force by viscous force. So in that experimental, so we are taking for the following setups, like first one is a glass tube, next one is a dye injection systems, and the third one is a flow control valve, and the last one is a observation tank. So before entering into this topic, so what is meant by laminar flow? Laminar flow, it is a smooth flow. So in that cases, it is a smooth and orderly fluid motions where particles moves in a parallel layer. So the layers, it will be in that parallel manner. So not it will be interact with each other. So there is no mixing and there is no other flow inside the laminar flow. This is called as laminar flow. If the characteristics are, number one is the smooth and parallel flow. Next one is the there is no mixing with each other. Orderly motion. So it will be moves in a straight linear manner. And next one is the low energy dissipation. These are all the laminar flow characteristics. So in that conditions, in that laminar flow having the low velocity, if the Reynolds number is less than 2100. Example for honey flow slowly. If you pour the honey from bottle to another bottle, means it will be pour very slowly. That is called as the laminar flow. Next one is a turbulent flow or transition to the turbulent flow. So in the transition means the particular period of time, the laminar flow, it can be transformed to turbulent flow. So what is meant by turbulent flow? Turbulent flow, it is a irregular motion. So it will be interact with each other. That is called as a turbulent flow. If the characteristics are chaotic and irregular manner. So, for example, in the turbulent flow, it will be in swirl or fluctuation. These are all the things in turbulent flow. So, in the turbulent flow, it moves the mixing of the one flow to other flow is very, very high. And it have a high energy dissipation. For example of a turbulent flow means the water flow through the river and air surrounding the plane and smoke rising from the cigarette. These are all the things are in that turbulent flow. So in that turbulent flow, Reynolds number between the 2100 to 4000 Reynolds number. So in that turbulent flow, already we discussed definitions, examples, and this also in that turbulent flow, the flow it will be processed in the turbulent manner. And Reynolds number. So what is meant by Reynolds number? Already I told you it is a ratio of inertial force by viscous force. If the equation is Re equal to rho Vd by mu, so rho it is a fluid density, and V it is a velocity, and D pipe diameter, mu it is a dynamic viscosity. So in that dynamic viscosity, it will be vary based on the fluid properties. So for example, while I am taking the water at 20 degrees Celsius, so if the density is around 98 kg per meter cube, and another one is mu, it is 0.001 Pascal. So in that Reynolds number, we will conduct the entrance length in the pipe. So in that entrance length in the pipe, we will take the two different flows, and first one is a laminar flow, second one is a turbulent flow. In that laminar flow, we will use the formula Le equal to 0.06 into Re into D. For turbulent flow, so here the Le equal to 10 into T. And Huygen-Moseley equations, in that Huygen, he's developed the one equations for that Reynolds x1. So if the equation is delta p equal to 32 mu L by d squared, so that in that delta p it is a pressure drop. So in that pressure drop, it can be calculated by output pressure minus input pressure. And while applications, where these experiments we are conducting and where it can be applicable. First one is a pipe designs. Next one is a viscosity measurement. Next one is a micro fluid. And next one is a oil pipeline. And last one is a biomedical industries. In the biomedical industries, the blood, it will be migrated from one place to other place or not. These are all the flow measurement of blood. So these are all the things we will conducted by using this Reynolds experiment. So thank you. We will catch you on next topic on next video.